Right, let's look at the next question. At a school athletics day, a stopwatch was used to find the time it took a group of athletes to run the 200-meter event. The results were recorded in the frequency table below. Right? And so, again, these values have been recorded in intervals. Right? And so we can represent this interval here by saying this will be 25. That plus that divided by 2. That plus that divided by 2 will give you 35. That plus that divided by 2 will give you 45. And then 55. Right? And so what we're saying is that 6 athletes completed the race in approximately 25 seconds. 16 athletes completed the race in approximately 35 seconds. Now, remember, these are not the actual values. That's the reason why I'm using the word approximately. Because some of them could have completed it. So in the 6, some of them could have completed it in 20 seconds, 21.5, 25.5, whatever it may be. But we're just saying, what's that one value that would represent that interval? Because we don't know precisely. Okay? And so if I have to expand this data set out, they'll have 6 25s, 16 35s, 21 45s, and 8 55s. Okay? And so you see exactly as they have it here. How many athletes ran the event? Add all of these values up, right? Because all of these data were taken from these people, right? And so if we add all of the data points together, we get 51. Calculate the estimated mean. Yet again, if I have to expand all of these data points, I'll have 6 25s, 16 35s, 21 45s, and 8 55s. So imagine, right? I'll do this 25 plus 25 plus 25 plus 25 plus 25 plus 25. 6 of it. What I can do instead, I could just say 6 times 25. Put that in brackets plus. 16 times, I'll have 35 16s, which is the same as 16 times 35. Yes? I'll have 21 45s, which is the same as 45 times 21. I'll have 8 55s, which is the same as 8 times 55. And so, yeah, if we do that repeatedly, we'll get, on average, right, what's that one value that represents all of these datum? Would be 41,08 seconds. So approximately, or most of the people, or most of the athletes completed the 200-meter event in approximately 41,08 seconds. The modal class, out of all of these, which class interval had the highest frequency? It'll be this one here. X greater than, X greater than or equal to 40 but less than 50, right? Identify which class the 30th percentile lies in. So remember, we have to find a position. How do we find the position? Go back to the position one. It will be the percentile over 100, so 30 over 100, into the total number of data, which is 51 plus 1, which gives us 50,6. Remember, this is a position value. It's a natural number. So therefore, it will lie between the 15th and the 16th position. Therefore, the 30th percentile lies in this interval. Right, so 15th and 16th, if I subtract, remember, we have to subtract coming from the top, right? So ignore this. We have to subtract coming from the top. If you have to arrange this data in ascending order, we would start here and go down, no? So that's the reason why we do that. And so 15 and 16 will lie here, okay? Because 16 plus 6 is 22, okay? And 22 is bigger than that, so it'll lie in here. 15 and 16 will lie in there. Okay, so you must keep that in mind. So it's very important. Yes, it's very important that you remember how is the data arranged, and it must be arranged in ascending order, and you do that, right? Because we basically saying the 0th percentile, 30th percentile, and then the 100th percentile. So we're doing it exactly like this here. We're starting from the smallest and we go to the biggest. This is why, obviously, they arranged it differently. We start from the smallest and go to the biggest, right? So that's why we do that. Okay. The next one is represent the data on a histogram using the attached diagram sheet. So it's very simple. Between 20 and 30 will be the first interval. How many of that do we have? We have 6. Between 30 and 40, how many of that do we have? We have 16. Between 40 and 50, 21. Right? Again, can you see why I say drawn to scale? Between 20 and 22, exactly half of this interval would represent 21. And so that's the reason why we trace it out there. It becomes 21. And then the last one, between 50 and 60, we have 8. Right? Yeah, 8. And then if you join all of that together and you shade it in, then you have exactly what you need. So yeah, that's how we solve that question. The next one, the following life science marks for a test out of 50 were recorded from 15 grade 10 learners at a certain school, right? So the marks are out of 50. We have the number, so there's 15 points here. So yeah, let's solve. Write down the median. Because we have an odd number of data, so we will be able to locate the middle point precisely. So it'll be 15 plus 1, which is 16, divided by 2, which is 8. And the 8th datum point will be 1, 2, 3, 4, 5, 6, 7, 8. Right, remember you have to arrange this in ascending order. And then here, if you count 1, 2, 3, 4, 5, 6, 7, because we have an odd lower half and an odd upper half, then we'll be able to locate the lower and upper quartile precisely. So that will be here and here. Okay. And remember, we say ignore the median. So that's how I did that. And right, so we got that. To determine the median of the data, add all of the data points together, divided by the number of datum, which should be 25,8. So what's that one value that represents all of these values here? It's 25,8%. Right, so most of the values are around that region. That's why we have 25,8. The range would be the biggest minus the smallest. It tells you the span of the data, which would be 39. Interquartile range, can you see? Q3 minus Q1, which would be 29 minus 17, which is 12. And if you have to represent this on a box and whisker diagram, yet again, we need to have a scale. So now here, because we're using the marks out of 15, I won't go all the way to 100. I'll just stop at 50. Let's say each bar would represent 50, and then you draw it to scale. See, this is 10, so it'll lie on that bar. The quartile one is 17, so it can't be 20. It can't be here in the middle of 20 because that will be 15. It'll just be slightly to the right of it, so that's how I got 17 there, right? If you want, you can break these intervals up into 15 and then further break it up until you get a very accurate answer, but you don't have to do that, right? You just judge it. 24, in the middle of 20 and 30 is what? 25. So it'll be slightly to the left of 25, which will be 24. And 29 will be slightly to the left of 30. And then the maximum value is 49, which will be slightly to the left of 50. Okay, for all of these values, and this is what we get there. The pass mark for life science test was 30. How many learners passed the test? So now remember, these marks are not given as percentages. It's given as a mark out of 50. Okay, and so what you're going to do is if you double all of these marks, right, and obviously with time you would train your eye to do it. If I double the mark, this would have been 30%. So this learner just made it. This learner just made it to pass. So these two learners did not pass. So 2 learners did not pass, but the rest of them did pass. So that would be 13 out of 15 learners passed. You calculate the percentage. So 13 out of the 15 learners passed. What percentage of them passed? And if you put that into your calculator, you will get 13, 86,6 recurring. So that'll be 86,67%, right? Of learners passed the test, right? And that other 2 did not pass. So if they tell you what percentage of learners did not pass, that will be 2 over 15. Ignore that, multiplied by 100. And that should give you about 13,33%, right? So 13,33% is the fraction of learners or the percentage of learners that did not pass the test. Okay, but the observation here, the important part, is that you realize that these marks are out of 50. So they're saying that 30% is the pass mark, right? I can't go and track these values and say, okay, this learner did not make it. I cannot say that this learner did not make it because this is not as a percentage value, right? It's just a mark value. And so we can't say 1, 2, 3 passed, right? Which is the mistake that you see here, right? Because you have to double all of these values, multiplied by 2, right? Or represent them as percentage values if you wish, right? So basically what we're saying is that this mark here is 29 out of 50 multiplied by 100. Only when you do this, then can you say you put them as a percentage form, right? But if you can think about it a bit ahead, the way you're doing it, you're just basically multiplying all these marks by 2 to get it to a percentage, right? Because 100 divided by 50 will be the constants. 100 divided by 50 is equal to 2. So you just take the mark and multiply by 2 and you'll get some percentage value, right? So very simple stuff there, but just knowing that observation was so important. Okay, so yeah, that's that. Let's solve the next problem.